So everybody, before we get started, I just wanted to talk a little bit about what the Ascent Open House is. Obviously, in the midst of the global pandemic, this unprecedented situation we find ourselves in, a number of events and conferences have understandably been canceled. We wanted to create some kind of forum where we could just connect with everybody, share some of the ideas we have at Ascent, talk to everybody about things that are going on, make up for those connections we would have been making at a lot of those events and conferences. So we threw together the Ascent Open House. It's going live today. At the end of this talk, I'll be sharing a link where you can access the page. But we're kicking this off with a keynote from Brian, the Ascent founder and CEO. And we're going to be talking today about thinking machines, ethical AI, and why it's so important in these tumultuous times. So with that said, Brian, let's just sort of start off by talking about why ethical AI matters right now. And to start, can you catch us up on the state of AI? What really is the state of AI at this moment?
Yep. Yeah, absolutely. So really, there's a lot of work being done publicly and privately in artificial intelligence. And I think the term first became prominent probably back in the 60s. And it was intended to be defined as any sort of automated process, any sort of machine-driven analytical process. The way I usually define it is anything 5 years from now that we consider normal. If you told someone that you could speak into your phone and it would convert that language into text, it would take that text, it would issue a set of instructions, and it would then organize some sort of work for you, people would say, oh, okay, well, that is the outcome that we've been looking for. That's artificial intelligence. So it's a bit of a moving target, but it's anything that we think is cognitively outside of a human process, or well, mirroring a human process at this point.
So obviously, things mirroring human process, but that are being done by machines are going to bring up some ethical questions, right? Societal issues that are around that, issues around usage. Do you want to just touch on a few of those topics?
Yeah, absolutely. So let's talk, and I want to give a little bit more on kind of an overview of AI and dive into those ethical issues. So sure. There's a couple of key concepts here, and what it isn't is AI is it's not going to solve all the problems. It's going to be a set of tools and processes and protocols that help in the way that a computer helps, right? A computer is a set of rules-based instructions. What AI is going to be is a set of rules-based instructions that the computer learns, the computer interprets. There's a couple different types that we can look at and that are used commonly. All of us are familiar with middle school geometry and trigonometry, but there's some pretty basic mathematical concepts. You probably heard y equals mx plus b. It's a trend line. That's a common form of what is contemporarily called machine learning or artificial intelligence. It's a trend line based on the way some data is positioned. So that's a very basic version, but there's really three key buckets that we hear about now: supervised learning, unsupervised learning, and then I'll dive into the second, or into the third, and the third is reinforcement learning. The first, unsupervised learning, that is, I have some set of data. I'm going to teach a machine based on this data. I have 15 different variables. I'm going to give it a couple of those variables and let it predict the other variables. And that takes a lot of different formats. These are things like traffic patterns, any basic math prediction, stock returns, things like that. It's how do I take what I know and push it forward into making a prediction in the future. And obviously there's a lot of research in financial markets about how to use these sorts of concepts. The second is what's called unsupervised learning. And that's things like clustering, having a machine say, here's a bunch of data, machine, make some sense of this. We'll give you some parameters. Tell me how this works. Now, without those parameters, the machine doesn't really know what to do with it. So that unsupervised learning is really a bit more of art than science at this point about how do we extract insights and intelligent information from this set of data. And the third is reinforcement learning and transfer learning. Reinforcement learning and transfer learning. Transfer learning is a bit like how a toddler will learn. If a toddler touches a hot stove or a hot pot of water and then sees another set of water, a human will know, okay, those are not the same things. But a computer may look at that and say, okay, it's the same thing because it hasn't learned that there are different variables, temperature, atmosphere, thousands of different variables that go into our computational sense of how this works. That's on the transfer learning side. Reinforcement learning, then, it takes those parameters and all these three buckets, and what it does is it sets a goal. So you can think about a video game where you're trying to achieve a high score. And you say, all right, computer, I want you to get to this goal, right? That goal the machine is going to iterate through all the different actions. So if you're playing a video game, it's 10 different buttons, and it's going to push those buttons in random sequential order until it maximizes that score. There's some really interesting stuff on the internet about this. If you think about a reinforcement learning mechanism in society, the biggest one we have is capitalism, competition, right? A bunch of different variables get together to create optimal businesses and outcomes. So we see a little bit of mirroring between the way the computers think and the way we've structured how we work. But those are the big three items. There's two final concepts I want to share. The first is the variance bias trade-off. What this is basically saying is the more complex something is, the harder it will be to automate. You're going to need more data. You're going to need to understand more. And humans work the same way. The bias is the focus. And bias has a pretty negative connotation in society right now. But something to consider with bias is it's not always bad. It's simply a collection or a clustering of data that is similar that allows you to extract some insight. Now, if you're trying to capture a wide variance and you get a lot of bias, that's very bad. We'll talk about that a little bit, especially in regards to ethical considerations around AI. Lastly, I want to talk about general versus specific AI. You hear it in the news a lot. Artificial intelligence is a concept that is pushed out and has a bit of a alarmist view. Unfortunately, or fortunately, that's much, much farther away. That's general AI. Computationally, a computer taking the world around it, understanding it, synthesizing it, and making a set of decisions. In contrast, where we're at today is much more in the domain-specific AI. That is taking a set of information, looking at that information, saying, based on these parameters, this box that I understand, I can accurately make predictions or do work. And so examples of domain-specific AI are things like stock return algorithms, or for what we do at Ascent, a set of regulatory algorithms. They're something that has a limited amount of space to compute, mostly because it's still to what's called computationally intensive. It takes too much effort for a computer to do anything other than a very specific focused set of work, no matter that it's called AI. So I'll stop there. And then I think we were going to dive into the ethical questions around AI, correct?
Yeah, definitely. So with that sort of parameter and that layout, what are the ethical issues that pop up then when you see systems like that?
Yeah, so there's a couple. I want to talk about a problem set that we've been considering and discussing a little bit internally. I refer to it as the unity problem, but basically it's the premise that technology is a magnifying glass. And as technology has advanced in the ages, it has allowed fewer and fewer people to do more and more stuff, more and more work, or more and more impact on society. If you think about weapons in the 1600s, or building structures, right? Limited impact the number of people. You fast forward to industrialization and the ability to control a plant and manufacture, you could help a lot more people or consequently harm a lot more people. And then you fast forward to where we're at right now, weapons, computing, things like that. It allows a smaller and smaller proportion of people to have a larger impact. And that's both the promise of automation in AI and also the peril of automation in AI. So this idea that I refer to as really the unity problem is something that we are already grappling with. If you think about one bad actor who can influence 1 million lives, there's all sorts of different permutations around how they can do this. But consequently, it only takes one person with a lot of computing power to solve the next disease. You know, we're currently facing a crisis in that scenario, or to figure out how to eliminate fossil fuels in a new type of engine that doesn't require gasoline combustion, right? So you have both sides of this, and it's that balance. There's a couple key questions that come out of these societal use of AI. First is, we hear about it now, it's about employment and inequality. There was a study done by Daber a couple of years ago that talked about how whenever we see automation in society, and this happened when we transitioned from farming to manufacturing and industrialization to the computing age, it eliminates jobs. But the point of capitalism is not to keep jobs, it's to build progress and create better welfare for everybody. And so you certainly will see some jobs disrupted. Really the purpose of AI is it builds knowledge. It builds knowledge like you or I would, but it does it faster and cheaper because it's a computer. And that will be disruptive. That will cause a number of folks who currently do knowledge work, be it anything from basic financial analysis to contract review and law to driving a car, to be automated. And that will be disruptive. But what Daber found is that actually there will be more people required to enter the field. So we're seeing a job shift. So The problem is that short-term period. How do we retrain? How do we support people? And the only concern that I have seen out there is that the rate of retraining a person is questionably slower than retraining an algorithm. And that's the thing that we have to look out for. Secondly, on the inequality side, what this does is it exacerbates existing inequality issues. There's a significant ethical debate out right now about the distribution of wealth and income in this country and really in the world. And because AI, and I'm getting a little bit on the economic theory, requires a lot of cash, a lot of money to build, the returns are not going to go to the people working, they're going to go to the people who have the money. And so that creates, you know, in the spectrum, it actually pushes people at opposite ends of the spectrum. And that is something that we'll have to consider. Think about Bill Gates when he built Microsoft, right? He built one computing program that tons and tons of people use. I think I read the other day that 8 people in the world control 50% of the wealth. You'll see this sort of stratification increase over time unless we get our hands on how AI really increases inequality and what we do about it, because they're machines. They don't need to get paid. There's no labor force. It's all fixed cost. And that's going to be a very big concern going forward. That's kind of the big picture stuff. Tactically, what does it mean? Right? What are the issues around what we're doing? And there's really 3 concepts: usage, risks, and controls. So I'm going to talk about 4 things here. The first is overfitting and memorization systems. So if you look at a lot of algorithms, really what they are is the system has seen everything, so it knows how to do everything. And that's not really an intelligent algorithm because you're not saving any time. You're not saving work, you're not creating value. The number one thing that you have to consider is what is the trade-off, right? So you don't want to overfit or memorize what you're doing. You put too much data in, you're making the system brittle, where it says, okay, unless I've seen something exactly like this, I don't know what to do. And humans do this, right? We're very, very comfortable with certain patterns, and we know all those patterns. And when we see something new, we say, oh, wait, I don't know that pattern. I can't do anything. I can't make a decision. And the key is actually taking a step back at what's underneath those patterns. What's the analysis? What are the lessons? Well, machines are the same way. When you tell them everything and have them memorize and they see something new, they don't know what to do. Now, not in the same way you or I, but the machine will not know what to predict, and it will take a bit more of a guess. Secondly, is on the overfitting. That's that taking a guess. How do I understand where the stopping point is for the amount of data? And that's economically efficient. You want to make sure that you aren't providing too much data to an algorithm in a way that creates inefficient commercialization. For example, if you are creating a data set of 100,000 different data points and you only need 50,000, every one of those data points requires a human to build it, or a human assisted with a machine. So you've added 50,000 units of work, right? In economics, this is just the decreasing marginal returns, right? Be careful that you aren't overdoing it when you have sufficient data to automate a process. Secondly, bias. We talked about this before. Bias isn't inherently bad by itself, but it is inherently bad when you're making decisions without understanding what that bias was. There's a famous case with Microsoft last year, I believe it was called Tay, where they trained the algorithm on Twitter and a bunch of other social data. By the way, when you get a bunch of data from the internet and you shove it into an algorithm, that's called a corpus. They trained it on a corpus of data from Twitter and these other social networks. And what they found is that a lot of that data had some less than conventionally accepted language and statements. And that trained the algorithm to be very biased, in particular, very discriminatory. These sorts of biases aren't just specific to the human connotation of bias. In the human connotation of bias, you know, discrimination on race, creed, religion, gender, all of these things are very well known. But for machines, you can have bias in anything, right? You can have bias in any data set. So it's really important to understand where you got it from, what all the context data around that bias is, and how it matters to the decision you're trying to make. For Ascent, when we have a set of algorithms, one of the things that we do that's unique is we've in-housed all of that algorithmic development. We don't use public customers and data external to our company to build our models because it introduces unforeseen bias. I'll give you an example. Bank A looks at a set of laws and says, all right, we're going to do all this. And they train a model, right? Bank B looks at it and says, okay, well, we're going to do all this. Inevitably, those may have a little bit of difference. If Bank B is getting outputs from an algorithm developed by bank A, they are introducing bias and risk into their system, into their world. It's contagion, if you will. And that is extremely risky. So it's really important to understand how that works and have a consistent process. Crowdsourcing, again, has its value, but there are a lot of places that it's very detrimental. And unfortunately, this is a common refrain we see in society now, especially in professional services. Everyone's trying to crowdsource algorithms, but what they should be doing is crowdsourcing a set of experts to create those algorithms. All right, moving forward. Third, unintended consequences. Machines are not going to do anything we don't tell them to do. The problem will be if we program them improperly, if we give them a set of instructions and require them to weigh some sort of individual variables that clash, and then they make a decision that we would consider suboptimal. People do this too. If you tell them, consider A, B, and C, but what you really mean is I want to look for outcome F, you haven't given them the right parameters. And so there's a mismatch. Machines will be the same way, albeit in a less complicated method at this point. You know, you can consider all sorts of defense criteria around certain weapon systems. And if you don't program those the right way, and this is the ethical debate around using machines and autonomous drones for military actions, it can create a lot of problems. So it will not be the machines themselves, it will be the humans programming them that create both the intent and the potential infractions. And lastly, that gets to really the ethical ending point. What do we do? And I actually really like the way that Isaac Asimov positioned it. He had his 3 laws that he put in robots. But really all you're saying is, these are 3 instructions that no matter what we tell you to do, don't ever breach these. It's base code. You know, in humans, we have base code as well. And generally that's how society is structured. It's don't hurt people, you know, be thoughtful. You know, they have different representations. But machines, if you can embed a set of ethical codes, it allows them to be used productively. And so Asimov's 3 rules, and I forget what the 3 rules are exactly, but in you know, one of them in particular is you can't harm humans. These sort of embedding these codes into these machines as base code will allow us to program on top of them and basically make errors, because that's what humans do. We make errors, machines don't. And that creativity allows progress, but without sacrificing the risk. So I'll stop there. That's a lot on kind of the societal and ethical issues.
That's awesome. Yeah. So transitioning from that, let's talk a little bit about how specifically AI helps the world. Why the world is so ripe for the use of technology like this, and then also the ethical considerations of using technology for work that's as critical to so many financial firms as compliance and risk is.
Yeah. So there's a couple of considerations. We'll talk about it generally, and then I'll talk about what we do here at Ascent. First, operationalizing AI. There's a question about agency and then a question about resourcing. So first, on the agency side, it's really important that humans own the decisions that ultimately impact the machines. So when you're looking at operationalizing an AI project, what direction do you want to go, right? How do you want that machine to work? And there's some examples in trading systems where people said, well, I don't know, I just set the machine and it did a bunch of crazy stuff and it caused the market to crash. This was called the flash crash a number of years ago. Well, at the end of the day, the human has agency in programming that machine. They're the one that are responsible for telling the machine how to work. And this is really, really important because the way that people think, the ethical considerations around how a person thinks about their life is going to be imputed into the ethical considerations in that machine. So if you have folks who may be a bit more socially detached, who may have you know, certain experiences or scenarios that they bring to their lives, they may lack some of the programming into a machine that may allow for harm to happen. And so it's really important to consider that human-machine connection. You know, is there sufficient learning and understanding of the ethical principles, compassion, kindness, thoughtfulness, empathy? These are really, really important. So that's kind of the starting point. You got to own whatever decisions the machine makes, and you got to be responsible. Number 2, internal resources. So there's a couple different considerations here, but there's really 2 that are important. Number 1, make sure that you have domain experts. Whatever you're automating cannot just be done with data science and engineering teams. Got to have someone who knows the discipline. In the case of self-driving cars. They've been training those algorithms with a bunch of human drivers. Now, that doesn't require a ton of expertise. But let's say it is a doctor reviewing radiology charts. You're going to want to train on data reviewed by that doctor who reviewed all those radiology charts. That's going to create an optimal outcome. So one is the domain experts. Number two is really the data science and engineering teams. Marrying the technologists with the domain experts is going to allow us, and I believe it was there's a Nobel economist who talked about how we always build on the building blocks of others. And taking those two pieces of technology and merging them together, the technology and the domain experts will allow us to build on those blocks and create value. So that's how you start to operationalize. Tactically, data science and engineering teams, having a domain experts team, and the software engineering team. And those are the three that really are important to commercializing this. Secondly, application to what we do at Ascent. So there's a lot of what we call knowledge work. And Ascent sells knowledge widgets, but knowledge work is done everywhere, right? It can be something as simple as every month I review a financial statement, or 100 times a day I make a phone call to a customer or a prospective customer, or I have 10 patterns that I take with my friends where I send a happy birthday message, right? Every one of those can be automated. It's just a question of the complexity of that task. The key here is that for what we do, there are a lot of steps to analyzing laws and regulations, understanding changes, reviewing data that is very, very time intensive and has a lot of human error. So instead, we don't use AI because it's sexy and it's good for our marketing campaigns. We use AI because it's a tool that solves our problem. It solves it better than humans. Let's take another analogy. In spaceflight calculations, you probably don't want human doing those by hand. For those of us who've seen Hidden Figures, the mathematicians used to by hand calculate trajectories, landing, all sorts of navigational elements. We don't want a human doing that. They're too slow. You need a machine. It's the same way for regulation and law. For us, if we had a bunch of people analyzing all these laws and regs, it'd be way too time intensive. It'd be way too costly. And that's actually how people do it right now. Armies and armies and armies of compliance and legal professionals analyzing text, and they're all doing the same thing. So instead, we deploy technology to do it for us, and we work with that tech. We review the outputs. We look at how it works. And we've been able to automate about 95% of the entire process. And this gets to the second point, human-enabled AI. If you think about factories 100 years ago, a Ford factory had 100 people in the assembly line making a car. Right? And over time, what they discovered is, okay, I can replace this person and put a machine in. The machine is 10 times more expensive up front, but after car number 10, we're making money. And so that happens step by step. This is just industrialization and automation. The same exact principle is happening in knowledge work. So if we go back to that Ford factory, look at a Tesla factory. It's actually machines a mile long in a giant warehouse just building things. What they have is, I believe they have one person who moves a door from, who knows, step 84 to step 85, because they've said it doesn't matter how much money we spend on a machine, it'll still be cheaper to do it this way. So that is that merge of humans are now quality controlling. They're reviewing the machine outputs. They have quality checks. They're looking at the outcomes. And now we're seeing that in the knowledge world. Instead, think of a digital assembly line. You take a set of actions, and let's take reviewing a financial statement as an example. You receive the data from finance and accounting. You look at the charts. You check your balance sheet. You look at your expenses. You look at your new customers and your revenue. And then you come up with a decision. Right? Okay, we are going to decrease our hiring or increase our hiring. Well, that decision is the function of 5 different steps of analysis. And so you can have a computer calculate what were your increased costs, what were your increased revenues, right? You can look at all of those steps and actually put that forward and say, okay, machine is recommending we hire 3 people, but that's what you're doing anyways. So that assembly line is actually just 5 cognitive steps that you've taken with a decision at the end. And it looks exactly like the Ford factory. The difference is it's digital. So then you mirror it. You say, all right, there's 5 steps to this cognitive process. We're going to teach an algorithm for every one of those 5 steps, or maybe 3 of those steps. Your algorithm is your machine in your digital knowledge factory. And that's ultimately how it works. So you pair those 2 things. And the outcome is faster, cheaper, and it's better. I'll take one more example on this, drug discovery. There's been a lot of news recently about, obviously, the COVID outbreak. And one of the remarkable outcomes that has happened is technologies identifying prospective drug compounds at light speed. In days, they're able to isolate 72 potential, I believe I read, 72 potential compounds that could serve as, and I want to say that the base for vaccines or potential treatments. This is happening in days instead of years. And that's because the machines have been trained on that knowledge work, how to identify that. And then the humans take that and they look at it and say, okay, we can work with this, this, and this. The humans have additional context. So that digital assembly line is really, really important concept for how humans work with machines. Humans on one side, machines on the other, and we build things together.
Absolutely. Yeah, I feel like, that gets that domain expertise piece that you were talking about, right? It's not just automation doing it, it's coupled with domain expertise. And then for regulatory compliance specifically, because we're automating a lot of that, tedious work, it then frees up those human experts to focus on more critical work that they were being bogged down with other stuff and weren't able to handle before.
Well, that's exactly right. Instead of spending thousands of hours or tens of thousands of hours reviewing laws, reviewing regs, doing knowledge crunching, if you will, our machines can do that. It can review regs, can review laws, it can review changes, and it can set all that up into a framework that allows you to take that forward. Say, how do I reduce risk? How do I find any gaps in my company? How do I look at my regulatory and legal risks? How do I make sure we're compliant with everything? That's the downstream work that you can do. How do I monitor, right? All of those actions you can't take unless you have all of this knowledge built. And that's an extraordinarily expensive, tedious, time-consuming, and frankly, gap-filled process. Humans are not good at it. And I say that as someone who did it before. So the application of this technology is really, really helpful. And I can give you a couple of use cases. We've done this with a couple of laws. In one, we reduced the amount of time spent from about 1,800 hours of human time to 2 minutes. And that's to get to the same benchmark, right? That's per law. We had another one where they spent $600,000 in expenses for reviewing one law called GDPR out in Europe. They put humans with our machines and our outputs, and they spent $3,000. So that is the order of magnitude. We're talking hundreds or thousands faster or cheaper than existing processes.
Definitely. So let's talk a little bit about the new current environment we've been plunged into also, right? So I know a big part of Ascent's story is that when you were working as a regulator, you saw that regulatory pendulum swing to the overregulation that happened after the global financial crisis that increased over that long bull market that we had. And now plunging into this new financial crisis that we're still trying to figure out. Can you talk a little bit about how regulation might respond to that, the importance of risk and compliance teams and their role in helping companies during a time like this, and then the importance of AI in helping those risk and compliance teams?
Yeah, we'll take those really in a couple key steps. So the first is risk and compliance, as unsexy as they are sometimes, are mission critical, right? The people who do that work are critical to the success of the business. They're the ones who carry the shields. Compliance is not a sword, it's a shield. It's a way to protect your firm and your business. And not only that, but protect your people, your peers. Because if you make a mistake and the business gets fined, people lose their jobs and their welfare. Right? That is really, really important conceptually to understand the pressure that our customers and folks face on a daily basis. There are really a couple key ways technology can help. First, as we talked about a bit before, really, how do we respond to these new environments? And there's a couple things we can do. First, and I'll go kind of generally and then into technology. You really have to be thoughtful about your processes and protocols, right? When you're using a completely manual process, that creates a potential disruption for any sort of geopolitical event, whether it be the 2000 tech crash, the 2008 financial crisis, or even the current pandemic that we're in right now. And managing your business through that is really, really important. And so having backup, having a digitalized center of all that information that you can make decisions with is really important. Make sure you have business continuity plans. Make sure you have things that allow you to lean on those processes so you can then apply your thoughts towards solving problems that you have to solve. Number two is really for risk and compliance. They are, like I said, they're the shield, right? They're the ones that protect the firm. They're making sure that there aren't missteps. There's a long tail to regulation. It always happens after the fact. So you can darn well bet that there will be a lot of laws, rules, regulations that come out regarding probably drug development, speed, to make those faster. Some will get rid of, some will add. How we handle pandemic response, medical emergencies, those sorts of things. I couldn't even ideate what they'll come up with, but I'm sure, as we know, in 2000 and 2008, there was a lot of laws. In 2008, we came out with Dodd-Frank, which revamped the financial system. I think Sarbanes-Oxley came out of the Enron scandal. In 2000, I believe there was regulation that came out after that as well about, that was Sarbanes-Oxley in particular, reporting, public disclosure, et cetera. So you always see these happen based on these geopolitical events, and we will see the same here. So lastly, you're going to see a lot of work go up for fewer people. You're going to have to do more with less whenever we go into market downturns. And technology, that's the whole point of it. Do more with less, right? Reduce your risk, reduce your cost. And that may sound too good to be true sometimes, but that's how it's always worked. Technology has always been the productivity gain that saves you money and helps you do things faster. And this is no different. It's just a new piece of technology that can do things that couldn't be done before. So in particular for risk and compliance, that's going to allow folks to analyze more data, to understand more regulatory changes, to look at the existing regulatory requirements, to see how are we impacted. Okay, having a computer build all this data, but then I can take actions on all of this. And that's fundamentally the value. Reduce the tens of thousands of hours on analyzing and allow you to make decisions. Humans are better at making thoughtful decisions because we understand more. Computers can do that work to get you there.
Absolutely. Yeah, and it's that cost reduction piece, right? Like as we enter what seems like it's going to be a bear market, firms are going to have to cut costs. The cost of compliance keeps rising. How can you use technology to reduce that cost? And then also, like, a tumultuous environment like this is when firms are going to be moving really quickly to take advantage of new opportunities. And you need that shield of compliance to make sure you're protecting yourself from moving too fast and doing the wrong things. You don't want to be cutting, the functional costs of your business that are helping support the revenue generating costs of your business too.
Yep. Yeah, absolutely. And the critical function there, as you stated, is how do we protect the firm? How do you do more with less? And giving people the tools to do that in a time that is a bit tumultuous is going to be important. Yeah.
So then let's just, to close, let's just think briefly, what's on the horizon for AI and specifically how it can help out regulatory compliance?
Yeah, so in our space, and I'll talk two things, one broadly about AI and then particular to Ascent. Broadly, I think you're going to see more knowledge work being automated. You're going to see more steps being automated. And the same as 2008 after the financial crisis, you saw software as a service, like portals that went up online that became digital sources of truth. Those started. I think this is probably the downturn that will start the automation engines around AI. It's going to be, how do we complete all this work, but we don't have a ton of people. We can go hire 500 of them. Well, let's have a couple data scientists build an algorithm with a domain expert, right? You're going to start to see that sort of trade-off. That's going to happen in any time there's a downturn. I believe it was Plato who said, necessity is the mother of invention. And that is what's happening right now. So a couple things with that, and then we'll dive into the reg compliance piece. First, you're going to see more controlled frameworks, more processes around AI. How do you commercialize AI? How do you operationalize it? How do you have better tools that support this development more expediently? It's when there was a gold rush, the people who did the best were the ones who sold shovels. So you're going to see folks start to build tools that actually do pipelining and automated analysis, and they'll do well. But what will come after that, and I think that's probably the era we're starting to enter, is how do you use those tools to solve business problems? And that is going to begin at a much faster clip over the next couple of years. In particular, in the regulatory market, it's really about understanding the knowledge work you can replace. There's a really important concept here. If you take an approach that you slap an algorithm on a data set and say, give me everything, what that algorithm is going to do is give you everything. So if you're used to reviewing 10 things and now you've got 1,000, you've actually created a ton more work because you haven't thought about how that human machine connection works the right way. So if I say, all right, machine, tell me every time in the laws that I want to see this piece of text. It's going to do that. No analysis, no thoughtfulness, no anything other than what you've told it to do. And so if I'm reviewing, I don't know, 20 pages a day and I run it across this data set, I might be reviewing 2,000 pages a day. And that means I need to hire a staff of 10 more attorneys. Well, that's not the point of AI. That AI just made more work for you and arguably didn't even reduce the risk because it's the same amount of data set you're looking at to begin with. The key here in our world is, how do I apply to actually give me the same outputs? The things that I would create, the data I would create, so that the thousands of hours I was spending, I may spend 5% of that. So instead of 1,000 hours, I spend 50 hours, or 1,000 hours, I spend 10 hours. That's the sort of work that needs to happen. So for us, reviewing regulatory changes, the only ones that matter to you. Reviewing laws and regs, the pieces of text. I think we had one where we took millions of words and reduced that to a handful of bite-sized actions. That's analyzing thousands and thousands of pages of human text and saying, here's the couple things you need to worry about to reduce your risk. And that way, the expert can take that and say, all right, here we go. I can review the audit, I can audit the computer, but now I know this is what I'm going with. And that will dramatically reduce their risk and save them time and money. In particular, we see this around regulatory monitoring, compliance monitoring of everything you have to do, around compliance changes, and just having that single source of truth. So lastly, a couple other use cases. In this environment, it's going to be expensive to enter new markets, require new customers. It always is, right? But when you're in a bear market, in a down market, firms focus more on reducing costs than increasing revenues. So if you want to enter a new jurisdiction, you want to add a new product, those are really difficult things to do if you had really primarily from a regulatory and legal standpoint. So what our system can do is actually say, here's everything you need to worry about. You can generate that in minutes and allow you to still focus on generating revenue in a bear market, something that isn't really a big focus at this moment. Secondly, it can actually reduce those costs. I think the reality of any market is people look for efficiencies in down markets, and saying we can do 3,000 hours worth of work in 10 hours is going to allow a really significant opening up of personnel and budget to do more higher order thinking and work. And then that's as particular to our industry.
Awesome, that's great. So speaking of opening up, I want to open it up for questions. If anybody has any questions at this point, feel free to drop them in the chat or just raise your hand. While we wait for some of those, I'm going to just share the landing page link in the chat too. And I also just want to plug a couple more conversations we have coming up as part of the open house. Tomorrow at 9 a.m., we're going to have Maria Phillips talk about the evolution of regulation. Then this Thursday, we're going to have a few team members talk about what we're calling the shortest commute ever, how to set up a high-functioning remote workforce. And then on Friday, we're also going to have digital transformation and financial services, how to make it work for you. You can find all the information about those talks, including registration links, in our landing page, the link I just shared. And if we have any questions, feel free to drop them in the chat there. Otherwise, I think we'll be able to wrap up. Great. Well, I appreciate you taking the time, Brian. I appreciate everybody hopping on to hear the call. Wishing everybody good health in these unprecedented times. Thanks so much. Thank you, Brian.
Thanks, Marcus. Thanks, everyone.
Thanks, guys. Bye.